Here are two more partial fraction decomposition examples for your review while you're working on your homework or if you have further questions. These come from the lecture notes that are posted on e-learning. The first thing you might recognize about this partial fraction is that the denominator is not factored, so we need to factor it. When we are faced with polynomials with 4 terms, it can help to factor by grouping. Look at the first 2 terms and look at the second 2 terms, take out the GCF of both of them, and then see if something matches. From this case, you see from the first 2 terms we can take out an x squared, which leaves x minus 1, and the last 2 terms share a -2, which also leaves x minus 1. If you want to check what I factored, you can just distribute again and verify that you get what you had in the denominator there. So because the x minus 1 shows up twice, that one factor can come out together as 1. We effectively have factored out that factor, and we're left with x squared minus 2 as the other factor. That came from these 2 parts, x squared and minus 2. So that gives us 2 partial fractions, one with a denominator of x minus 1. That fraction's linear in degree, so the undetermined coefficient is a constant. And the next fraction has a denominator of x squared minus 2, which is quadratic and won't factor. So the coefficient is bx plus c. That gives us the resulting system that x on the left-hand side equals a times the denominator it does not have, x squared minus 2, plus the numerator bx plus c times the denominator it does not have, x minus 1. Here's where we have the choice to decide how to find a, b, and c. We can write the system that gives us the equation x equals ax squared minus 2a plus bx squared minus bx plus cx minus c. That comes from distributing and simplifying the right hand side of that equation. And we can write the system of coefficients. Notice that we have an x squared term in the right hand side, so we'll start our system with the x squared guys. On the right there are a, but on the left there are none, so that means that 0 equals a, and we also have an additional b x squareds. The next coefficient of x's we would be considering is x, the next power. On the left hand side there is 1x. On the right hand side we have minus b and plus c, so negative b plus c. And then we need to deal with any constant terms, any numbers. Again, on the left there are none, so that is 0. On the right hand side we have negative 2a and negative c. So negative 2a and negative c makes this system. So you have the opportunity to solve this system. You can do it with substitution or elimination, or remember we could choose some convenient values of x and solve for it that way. So remember our equation is x equals a times x squared minus 2 plus bx plus c times x minus 1. We want to look for convenient choices for x, so perhaps we choose 1 first. If we let x be 1, the last term will cancel, so each x gets replaced by 1. 1 equals a times 1 squared minus 2 plus b times 1 plus c times 1 minus 1. You can see this last term, 1 minus 1 makes 0, so all this stuff is gone. That's handy. And now we have 1 squared minus 2, or negative 1a, equals 1. So now we know that a equals negative 1. We need to still find b and c, so you can go over to your system if you wrote it, or we can choose another convenient value for x For example, I'd like to let x be 0 next. That's an easy one. 0 equals a times 0 squared minus 2 plus b times 0 plus c times 0 minus 1. That gives that 0 equals negative 2a minus c from the right hand side. B times 0 is 0. 0 minus 1 is a negative 1. Negative 1 times c is negative c. So that, in conjunction with the fact that we know a is negative 1, says that 0 equals 2 times negative 1 minus c. Oh, this is negative 2 times negative 1 minus c. So 0 equals positive 2 minus c. Now we know that c equals 2. We need to still find b, so we want to pick another convenient value for x and substitute the other values in. We've used 1 and 0. I would rather not use the square root of 2, which would get rid of that factor. You could, but then you'd have square root 2 here and here. So instead, let's choose to let x equal negative 1, or if you don't like negative numbers, you could use positive 2 or something. All those substitutions say the left-hand side negative 1 equals a times negative 1 all squared minus 2 plus b times negative 1 plus c times negative 1 minus 1. That simplifies to negative 1 squared is positive 1 minus 2 negative a plus negative b plus c times negative 2. So negative 1 equals negative a plus 2b minus 2c. We know a is 1 or negative 1, and we found that c is 2, so we can make those substitutions to solve for b. Negative 1 equals negative a plus 2b minus 2 times c. Means that negative 1 equals 1 plus 2b minus 4. Negative 1 equals 2b minus 3. Add 3 to negative 1, you get 2 equals 2b. Therefore b equals 1. And we have all the undetermined coefficients. Once we get those coefficients, we plug them back in upstairs. Finish up our partial fraction decomposition. A is negative 1 over x minus 1 plus b, which we just found to be 1 times x plus c, and c is 2 over x squared minus 2. So that's an example with a linear factor and a quadratic factor. Neither of them are repeated in the denominator, but we did have to remember how to factor by grouping. That's one good factoring strategy to keep handy, or if you get stuck. Okay, so that does it for example 33. I'll come back and do another video for the next example. Okay, here's another partial fraction decomposition where you can see that the denominator is quadratic and it's also repeated twice. That means that we need to use each of these denominators in increasing powers until we get to the power we have, which is fortunately only 2. So the first denominator is x squared plus 4 to the first power, and then we'll have x squared plus 4 to the second power. Now, since these denominators are quadratic, the numerators must be linear. Ax plus b and cx plus d. You can see how these numerators having more to them is going to make this problem a little more challenging. Remember, we want to solve the equation where the left-hand numerator, 2x squared plus x plus 8, equals the right-hand numerator after we got a common denominator. The numerator in the first fraction, ax plus b, would need another x squared plus 4 to have the x squared plus 4 squared. And the last numerator, cx plus d, doesn't need anything, so it would show up all by himself. This gives the equation 2x squared plus x plus 8 equals ax cubed plus 4ax plus bx squared plus 4b plus cx plus d, which gives the linear system of coefficients. We'll look at the highest power of x first, which is cubed. Then we'll need to examine x squared, the x's, and finally any constants. The x cubes were only 1, and on the left-hand side there were none, so we get that 0 equals a. Then we will look at the x squareds. On the left-hand side we have 2. On the right-hand side there is bx squared. So now we have that 2 x squared is equal to b. This is starting to take shape nicely. After that we need x. There's 1x on the left-hand side, on the right 4a of them. Not 4b, but c has an x. So on the left, 1x equals 4a plus c. And in the constant department, we have 8 on the left, 4b, and a d. So 8 equals 4b plus d. From this system, we already have 2 numbers. That was pretty handy. A equals 0 and b equals 2. So we can make those substitutions to solve for the remaining ones. This would mean that c equals 1, since a is 0. And if b is 2, and we substitute that in here, that must mean that d equals 0. That was a pretty simple system to solve. We could also solve it in the alternate method, choosing substitution values for x, but in this case the linear system did the trick pretty quickly. So finally we can write the partial fraction decomposition with x squared plus 4 as a new denominator, and then x squared plus 4 all squared as a denominator. If a is 0, that term just doesn't show up, so that makes our numerator only b, which is 2. And in the next fraction, c is 1, so there's 1x, but d equals 0. So our partial fraction decomposition is 2 over x squared plus 4 plus x over x squared plus 4 all squared. So don't get intimidated if they look a little tricky. Sometimes the answers work out rather nicely. I did try to choose examples, homework problems, and exam problems that have nice, easy solutions like this. So feel free to email me if you have any questions, and have a great weekend.